Alright, so this is exercise 2 of the Using Macros course, and in this exercise we'll use some of what we just learned in the last couple of videos, specifically how to use macro variables and logic, and then also how to use a dialog to report out to the user. So here's the exercise. You can see it's a statics problem. You have 3 objects resting on the table. They each have their own weight. So the top one is 2 pounds, and then the second one is object B is 3 pounds, and then the last one down here, object C, is 4 pounds. And there's a different coefficient of friction between each of the objects, and then between the bottom object and the surface it's resting on. And the question is, what horizontal force do I have to apply here on the top object in order to get something to move? And it's tricky in the sense that we don't know what's going to move. It could be that the top object moves by itself, or it could be that the top and the middle object move together, or maybe all 3 objects move together on the surface. And so it's a interesting problem in that you have to simulate all 3 situations, all 3 cases, and then the one that actually happens is the one that requires the smallest amount of force, right? So this is a great opportunity for us to use a macro to automatically simulate all 3 cases, and then as we do this simulation, keep track of what the force is that would cause that case to happen, and then at the end make sure that we're reporting out that the case with the smallest force is whichever one it is, and the smallest force is whatever value that force is. So that's the exercise, and we'll give you some time to go try it, and then once you've tried it, come back and we will walk through how to do that together. Alright, so I'm going to go ahead and try to solve this, and I'm going to start by just setting it up so that I can solve each of the cases, and I'll do that using tabs. So I'm going to have, I guess, 4 tabs. The first tab is going to have just the inputs to the whole problem in it, so I don't have to put that in every tab, and then each of the other 3 tabs will have an analysis of the first case where object A slides, and then the next one will be the second case, and the third one will be the fourth one will be the last case. So let's add a tab here. Let's call the tab inputs, and in this tab I'm just going to put the inputs, right? So these are going to be things that are just common to every case. So these would be like the weights. So WA is what, 2 pounds force. WB is, I think it was 3 pounds, and WC was 4 pounds. And then this will also have my coefficients of friction. So this will be 0.6 for mu1, 0.3 for mu2, and then finally 0.1 for mu3. So that's my inputs tab. I can solve it. Everything looks good. And now I'm going to add another tab, and this will be, let's call it case A. So this is the case where only the upper object A, slides. So the first thing I need to do if I'm going to analyze this case is use these inputs. So I can use a $insert tab directive to take all the equations that were in the inputs tab and put them into this tab as well. So this is pretty handy. And then I'm just going to solve, right? So the solution is that I guess this is book A slides, and it's going to be N. So this is my normal force. If only book A slides, then my normal force is only the weight of A, and then my friction force at the point where the sliding is just impending would be mu1 times N, and sum of forces in the x direction equals 0. It says my force that I'm applying has to be equal to F, and I'll solve this, and I'll see it will take 1.2 pounds to make just book A slide. I'm going to go ahead and set these units. Yeah, so that's all my units. Okay, so that's case A done, 1.2 pounds. Now let's add another tab. We'll call this one case B. And case B now is, again, I better insert the inputs tab. I have my normal force now is WA plus WB. So this is, maybe I should label this. This is objects A and B slide, but not C. Force of friction is going to be mu not 1 but 2 times N, and P is equal to F. So case B will happen if I applied 1.5 pounds. So case A was 1.2 pounds. That means case B is not going to happen. Case A is. Unless case C happens. So let's add one more tab. So case C. Again, $insert tabs, $insert tab inputs. And then in this case, I'm objects A, B, and C all slide. So I would have a normal force of WA plus WB plus WC. The frictional force would be mu 1 times N, and P is equal to F. And you can see then that not mu 1, I'm sorry, this is mu 3. This is the bottom surface, so this would be, yeah, 0.9 pounds. So I've solved the problem in the sense that if I wanted to, I could manually now go to case A, solve it, say, yeah, it looks like 1.2, go to case B, solve it, 1.5, and then go to case C, 0.9. I know case C slides. But what we're going to do is automate this, right, which is obviously something you'd want to do if you wanted to make this more user-friendly. So I'm going to open the macro window, which I did right here. Let's move this over. Maybe I'll move this up a little bit, give myself some more room. So I'm going to what? I'm going to first of all go to the right equation window, so that when I solve, when I execute the solve command, I know which case I'm solving for. So that is equation window tab, and I give it the name of the tab or a number, but in this case the name is case A. So that's going to emulate me selecting case A. In fact, if I wanted to, I could record that. Then I'm going to solve, and the force associated with case A, I'll call PA, and that's equal to P, right? And I'm just going to keep track of the minimum value of all of my different forces as I go through these different cases, right? So right now the minimum value is PA, so as far as I know this is going to happen. And if I want to make for myself a message that I will eventually put up, it would be that object A slides alone at P equals, and then I'll concatenate that with string dollar P min, and I guess I should put some units, pounds force. Alright, so that's the first one. The next thing I'm going to do then is go to the next tab. So I will now do equation window tab, I guess it's case B. Again, I want to solve. Now P sub B is equal to the solution for P, and I have to decide whether P sub B is less than or equal to P sub A. So if, let's do it like this, P sub B is greater than P sub A, then I'm done. I'm going to go on to the next case because this obviously isn't the one that happens. So let's do go to 10. And down here I'll put 10. And that'll be where I go on to do case C. If it's less than, if P sub B is less than P sub A, then I know that actually case sub B happened. So I got to reset P sub min equal to P sub B. And I probably should remake my message here to be appropriate. So this is going to be objects A and B slide together at P equals P min. So hopefully that makes sense. Alright, so now I've collected the minimum of A or B, and the last thing I got to do is C. So equation window tab case C, and I'll solve, of course, and P sub C is equal to P. And finally I got to decide, is this my biggest one or not? So let's go ahead and do that. So let's see, if P sub C is greater than P sub min, then I know this wasn't the one that happened, so let's skip the next couple steps and go to, I can't duplicate 10, we'll go to 20. So down here is 20, which is where I get done. If P sub C is less than P sub min, then I know that P sub min has to be set to P sub C. And I know that, let's go ahead and take this and put it down here. And so this is objects A, B, and C all slide together at P sub min. So at this point, I should have collected the minimum force. I should have made a nice message that tells me what happened, and I can use my message dialog to display it. So maybe I'll do something like message dialog, OK and cancel, and $. And hopefully that works. Let's see. So if I run it, you can see it does A, it does B, and there it did C, and it decided correctly that objects A, B, and C slide together at 0.9. Right? If I go back here, let's just maybe make this coefficient of friction a lot bigger, so that clearly that's not going to happen anymore, and run it again. So right here I can press this button, play macro, does the same thing, but it decides that in this case object A slides alone at 1.2 pounds. So hopefully you can see sort of the value of this. You know, there's a lot of times when you're solving problems that you might want to evaluate different cases in some kind of automated way and then report out which case actually happens, or you know, what the relative merit of these different cases are.